Today we're going to look at factorising by completing the square, and our learning goals for today is we're going to be able to factorise by completing the square, whatever that means. So here, let's find out what it means. Completing the square. Sometimes we're given a quadratic that we want to factorise, but we can't use the normal method that we've been looking at in the previous video of factorising quadratics, because mostly when we got ax squared plus bx plus c, we can do that. We can have a look for those common factors and try and factorise that. But what if we don't have this plus c, or what if that plus c doesn't match up easily? What if we're not given a c that we can easily find factors for a times c that add to b? What if we can't do that? Well, completing the square is one technique that we can use to factorise. And sometimes it works, sometimes it doesn't. But maybe our conclusion is going to be, hey, we cannot factorise this by completing the square. So let's have a look at what this actually means. It involves determining this missing piece, this missing c here, to a square. So we can add this missing piece in and factorise the square. So for our example down here, our little square, we've got a side length x and 3x and 3. And what we've got is the area there is x squared because it's x times x. We've got this area here is 3x because it's 3 times x. And this area here is also 3 times x. If we were to factorise this, we couldn't do it because we've got this missing piece here. Factorise would mean to make it one number times another number. So if we were to try and say, hey, we want it to be x plus 3 squared, that's wrong because we're missing part of our square. We're missing this part here. So we can't say that. But what we can do with the magic of mathematics is we can say, well, let's add on that missing bit and take it away. So if we add on the missing bit there, and we know that if our side lengths are x and 3, then this part here is going to be 3 times 3, 3 times 3. Okay, that missing part that we've got there. And then if we take that away, that's going to be equivalent. It's going to be equivalent again to our part here. Now the cool thing then is we know we can factorise a difference of perfect squares. So if we get our perfect square here, x plus 3 squared, because now that's x plus 3 squared, and we're taking away 9. Well, if we look at this guy here, we can see it is a difference of perfect squares. So if I wanted to factorise that now, I can say, well, that's equivalent to x plus 3 plus 3, because 9 is 3 squared, and x plus 3 minus 3. And we can simplify that and we get it in a factorised form. So here are our steps for completing the square. And remember, having these diagrams might be able to help you. So if you are struggling at all with any of these, we can have a look at trying to draw a diagram to see if we can solve it. But if we get a format of x squared plus bx, that's what we can, and we're asked to complete the square, factorise by completing the square. Firstly, we add b on 2 squared. Why b on 2 squared? Well, for our one here, this guy here, it's x squared plus 6x, yeah? So b on 2 is our 3. And if we add b on 2 squared, that's going to be our missing piece, because we're adding here 6 on 2 squared, that 9. Now, we can't just add something and keep it the same. We've got to add it on and then take it away again to balance it out. So we add our b on 2 squared, and that gives us something that's able to be factorised, tick, and then we can subtract that b on 2 squared away to balance the number you've just added. So this is about balancing out and making sure it's going to be equivalent to what we started with. Then we factorise the perfect square and simplify it. So that means the perfect square is the first part that we've dealt with. The perfect square now is this thing here. Factorise that thing. So if I factorise this, that's x plus 3 squared. It's a perfect square now. And then, if possible, it says factorise further by using the difference of perfect squares. So in our case, it was x3 x plus 3 squared minus 9. We've got that minus 9 there. So it's a difference of perfect squares that we've got there, and then you've got a fully factorised form. Okay, let's look at some examples now. For our first one here, we've got a is x squared plus 8x minus 3. Now, if I'm trying to use my technique before, a times c is negative 3, b is 8. I go, yeah, man, I can't think of two factors, two things that multiply to give negative 3, because I got, what, negative 1 and 3 and 3 and negative 1. They don't add to 8. That's going to be impossible. So what can I do? Well, I can complete the square. So what have I got here? I've got my x. This is the bit that I'm going to care about to start with, the x squared plus 8x, because I can use the completing the square on that bit, and the minus 3 we can deal with later. So what have I got with the x squared plus 8x? Well, I got here a shape, looks kind of like this, except nothing like that, kind of like this. Here, I got my x squared, and I got my 4x, and I got 4x, and they add to being 8x. So I can see I'm probably going to have x plus 4 along this side and x plus 4 along this side. And I got this missing bit here. I can't factorise this yet. I can't make it 4x plus 4 squared. So here, what number is going to go here? Well, it's going to be 4 times 4. It's going to be 16. And to make it equivalent, I need to take that 16 away, okay? Because I can't just say, well, I'm adding this thing on and I'm not going to change it. So let's have a look. X squared plus 8x minus 3. Well, that's going to be equal to x squared plus 8x, and now I'm adding 16. I'm adding the 16 on there because I can factorise that then. So adding 16 on, what am I actually adding on? I'm adding on b divided by 2 squared. So b is 8 divided by 2 squared. That's what I'm doing each time, b over 2 squared. Now I've still got my minus 3 there, and I've added on that b over 2 squared, so I've got to take it away as well. 8 over 2 squared. Now I can factorise the first 3 terms here, because this here, x squared plus 8x plus this thing squared, that's going to be equal to x plus b over 2, which is 4 squared. And I can see that. I can see in my diagram over here, I've got x plus 4, I've got x times x plus 4 here. I multiply those two together, and I get x squared plus 8x plus 16. All right? So I've still got my minus 3 here, and I'm taking away the 8 over 2 squared. So I'm taking away that. 8 over 2 is 4. 4 squared is 16. All right? So this is equal to x plus 4 squared minus 19. Now, believe it or not, this is a difference of perfect squares. Have a look. Minus root 19 squared. So I can factorise this using difference of perfect squares. I've got a squared minus b squared. So I can take a plus b times a minus b. So here, a plus b is x plus 4 plus root 19. X plus 4 is my a, minus b, minus root 19. There we go. All right, so that's our factorised form of x squared plus 8x minus 3. Done. One thing times another thing, we've factorised it. Let's look at b. b, again, if I look at AC, that's equal to 8. b is equal to negative 2. Very difficult here, okay? Two things that multiply to give 8, add to give negative 2. I can't do it. I can't do that. I could go through all the factors and I think, well, I can't do that. I better factorise by completing the square. First thing I look at is the x squared minus 2x. So that means I'm going to have essentially here, if I look at doing a diagram up like this, I get my x squared, got my x squared, and then I've got minus 2x. So this is going to be minus x, and this is going to be another minus x. So that must mean I've got x minus 1 and x minus 1. There. X kind of looks like a, well, I don't know how I'm going to make that look better. Do it on the side maybe. X and then minus 1. There we go. That's probably going to be the best that we got. Okay, x minus 1 times x minus 1. So that means this is going to be negative 1 times negative 1. This is just going to be positive 1 here. Positive 1 here. But we can figure that one out as we go, because we can say, all right, I've got my x squared minus my 2x plus my 8. Not worrying about the plus 8 right now. But here, this is the same as x squared minus 2x, and now I need to do plus b on 2 squared. So b plus b is minus 2 on 2 squared plus 8, because we can't forget that plus 8, and I've added on that b over 2 squared. I've got to take it away. So take away b on 2 squared. All right? So now, this is x squared minus 2x. Now, negative times a negative is a positive. So if I've got negative 2 divided by 2, I get negative 1. Negative 1 times negative 1 is positive 1. So this is going to be plus 1. Plus 8 is going to be minus 1. So I can factorize this thing here now. I know factorizing it's going to be x minus 1 squared, because it's x minus b over 2 squared. And I've still got my plus 8, still got my minus 1. So this is going to be equal to x minus 1 squared plus 7. Now, do I have a difference of perfect squares? I tell you, this doesn't look like a difference to me. It looks like I'm adding them. So this, I cannot factorize any further. This is not factorizable. I can say, therefore, I cannot, well, we can say this cannot be factorized. This cannot be factorized. That's our conclusion. So I might ask you to factorize it. Maybe it's not possible. Okay, maybe you have to say, well, I can't factorize it because it's down to a difference. It's not a difference of perfect squares. Last one we've got here, C. I've got x cubed plus 3x plus 1/2. Gosh, a here, oh, x cubed, that's probably not right, x squared. Here what we've got is, it's going to be very difficult finding things that multiply to give a half and add to give 3, I tell you. So let's just go straight to the difference of perfect squares. Let's not draw a diagram this time, and let's have a look at how we might do it if we just follow the procedure. So the procedure is, we have x plus the 3x, that's the bit we care about to find the difference from the completing the square. So all I need to do, I need to add on b on 2 squared. So b is 3 on 2 squared. I've still got my half here, and I need to counteract that adding b on 2 squared by taking it away. So take away 3 on 2 squared. Now factorizing this, I'm going to get x plus b on 2 squared. So b on 2 is 3 on 2, all squared. That bit now, this bit here, is factorized into that. I've still got my plus half, I've still got my minus 3 on 2 squared. So let's try and simplify the other bit now. I've got x plus 3 on 2 squared plus 1/2. Now this is going to be minus 9 over 4, because 3 on 2 squared is 3 on 2 times 3 on 2. So we multiply the numerators, multiply the denominators. If I have a half, I take away 9/4. You can do that on your calculator, but I mean, you don't have to. Same base there, or same denominator rather, means I'm going to have that as 2 over 4 minus 9 over 4. So it's going to be minus 7 over 4. Minus 7 over 4. Hey, difference of perfect squares time. So here we go. I've got to put it into a form that's going to be easy to factorize as difference of perfect squares, because I want to know, hey, this is the square root 7 on 4 squared. I've got my a squared minus b squared. So a is an x plus 3 on 2 plus b. Now b is root 7 on 4, but the root 4 I can simplify to just 2. So I'm left with root 7 on 2. Root 7 on 2. There, times x plus 3 on 2 minus root 7 over 2. Not fully simplified yet because I've got the same denominator for my two fractions there. I can make that look even prettier and have it as 3 plus root 7 over 2. And then x plus 3 minus root 7 over 2. So just to recap, we've had a look today at how to factorize something by completing the square. And remember, you can get it working if you get it to a difference of perfect squares like we have at this point here, but sometimes it won't work and you say therefore it cannot be factorized.